point 3, we switch gears into vectors. And to just put it plainly, a vector is a line segment that has a direction. All right, so a line segment has a finite length. All right, it has a beginning and an end. A vector takes that beginning and end, points it in a specific direction. All right, so we're going to find these geometrically. We're going to find magnitude and direction. We're going to do addition, subtraction, and scalar multiplication, component form, unit vector, operations, and then the dot product. Okay, I've already kind of explained to you what a vector is. So it's a specific quantity drawn as a line segment. It's got an initial point, beginning, and an ending, terminal point. It's defined by its magnitude, that's the length of its line, and its direction by the arrowhead that points the direction that it's going. Therefore, a vector is a directed line segment. In different ways, you're going to see representations of vectors, bold, lowercase. Okay, sometimes these should all have arrows on the top. I missed that completely. With an arrow on top of them, but generally bold and lowercase. You could also see it written as the initial and terminal point with the arrow above it, or as its components. This tells you how far, this is your horizontal, and this is your vertical. So how far left and right and how far up and down, basically a point. That's called your position vector. To rewrite any vector in its position vector, you need to know its initial point and its terminal point. Okay, and it's generally the order in the vector CD. So C is your initial, D is your terminal. Then the position vector is x2 minus x1, y2 minus y1. Best way to think of it is terminal minus initial. All right, so I can see vector CD here. All right, C is at 2, 2. D is at 7, 4. Okay, to find its position, AB, so we'll do terminal minus initial, so X's, terminal minus initial, Y's. So this means I go 5 units right, and then 2 units up. Find the position vector given V that has the initial point at negative 3, 2, and terminal at 4, 5, and then graph both. So we're going to go ahead and graph the initial vector, negative 3, 2, and 4, 5. And then make sure you draw the arrow at the end. All right, so vector V would be terminal minus initial for the X, terminal minus initial for the Y. So vector V is 7, 3. So starting at the origin, we're going to go 7 units right, 3 units up. And don't forget your arrows. Moving on into finding the direction and the magnitude. So if we know the position, then we can find the magnitude by using the Pythagorean theorem. All right, because we know 2 sides of that right triangle, we can find this length by using that Pythagorean theorem. Then in that same thought process, we can find the direction, the angle, by using inverse tangent, because we know opposite over adjacent. Okay? So we're going to do that. Find the magnitude and the direction of the angle with initial point P at negative 2, 3 and terminal point Q, 5, 7. We're going to draw the vector. All right, so the first thing we're going to do is find the position vector. Terminal minus initial, terminal minus initial. So that's 7, 4. So we go right, 7, up, 4. Draw your vector. And don't forget the arrow at the end. Magnitude. So magnitude is designated with the absolute value bars around your vector. A squared plus b squared. So that's 49 plus 16, 63. 65. Okay, I was off. Okay, that does not simplify, so we're going to leave it alone. Okay. Your angle, your direction angle, first off, this is a reference angle. All right, this theta that we get right here is reference. All right, it all depends on the quadrant that you end up in. All right, our vector in this case puts me in quadrant 1, so my angle will be positive, and it will be the reference angle itself. Let's see. Inverse tangent, absolute value, b over a. We're going to do that in degrees. Was it 4 over 7 or 7 over 4? 4 over 7. It's 29.745 degrees. All right, and that makes sense because this angle is clearly acute, less than 90 degrees. We're in quadrant 1. The angle's going to stay the way it is. All right, you can also add and subtract vectors. Okay, the geometric way of thinking about it is when you add two vectors, let's say I'm adding u to v, so I'm doing this. All right, I'm gonna sketch u. I'm not gonna do a very good job of it, so I'm just gonna, actually what I'm gonna do is this. And we're gonna move it. Okay, now when I draw a vector v, all right, so I'm going to go ahead and sketch that. So when I move it, my initial point here has to start on the terminal point there. Okay, so I'm going to get that out of the way now. The new vector starts at the beginning of u and ends at the end of v. And your direction is towards that terminal point for your second vector. So this is called your resultant. And you label it as u plus v. Okay? Subtraction. Okay, subtraction is exactly the opposite. You're adding the opposite. The second vector, you're going to go in the opposite direction. So I'm going to sketch this. All right. Now, when I subtract v, my initial point is actually going to start at the end. We're going to go in the opposite direction. So instead of going up and right, we're going to go down and left. And again, that starts at the terminal point of the first vector. And then the subtraction beginning of the first, end of the second. Still called your resultant. That's a terrible error. U minus V. Well, that's geometric. This is the visual representation of adding or subtracting a vector. Algebraically, it's literally just a matter of adding or subtracting their common parts. So U plus V. I'm going to add the two x coordinates. We're going to add the two y's. Subtraction, same idea. Subtract the parts. So 4, -6. Scalar multiplication is like the amount you extend or condense a vector. So you're like changing the size of the vector. Same direction, different magnitude. All right, so it's just a matter of distribution. We have vector u, vector v, and we're finding vector w, 3u plus 2v. So we're going to find 3u. So this is 9, -6, 2v. Distributing, I distributed here. That's where I get the 9 and -6, and distribute here. And then we're going to add the two parts. 9 plus -2. -6 plus 8. All right, finding component forms. In some applications, it's helpful to break a vector down into just its horizontal or just its vertical. And that just comes from separating them out with a vector of 0. So instead of having our 3, 4, we have vector 1, which represents its horizontal, so that'd be 3, 0. Vector 2, which represents its vertical, 0, 4. So find the components of vector v with this terminal, with initial and terminal side. So vector v, initial minus terminal, initial minus terminal. So that's 4, 2. So vector v1 would be the horizontal. So 4, 0. Vector v2 would be the vertical, 0, 2. Other times it's going to be useful to find something called a unit vector. So it's a vector with a magnitude of 1, but in the same direction as your original vector. All right, so it's written in an ij form, okay, similar to how we just did this component form. I is your horizontal movement of 1, and j is your vertical movement of 1. All right, so the position vector, when you're finding a unit, ai plus bj, where I is horizontal, j is vertical, which is literally the same thing as saying as vector v equals ab. Unit vector, okay, is dividing everything out through by its magnitude. So it's vector v divided by the magnitude of v, which creates the unit vector. Find a unit vector in the same direction as v. Okay, so a vector with a magnitude of 1. First thing we do is find the magnitude. A squared plus all right, so you're going to divide the vector. And you can do this in a couple different ways. I think I've shown the work differently on both of these. So the unit vector would be the components divided by the magnitude. And in unit vector form, it'd be negative 5 over 13i plus 12 over 13j. Given initial and terminal, write the vector in terms of I and j. So first thing we need to do is find vector v. So terminal minus initial. Terminal minus initial. All right, find the vector in terms of I and j. So vector v, this would be 3i. J. Find the sum of v1 to 2i minus 3j, v2 is 4i plus 5j. It is literally the same thing. So v1, v, x's, add your y's. If you really want to get picky about it, we can put it back in its ij form. That's my problem here. 6i plus 2j. Using magnitude and direction to write your angle, to write your vector. All right, so we know from the unit circle, unit 5 and all that, x is cosine, y is sine. So to actually identify the x and the y, your vertical and your horizontal, x is magnitude times cosine, y is magnitude times sine. So we write it as magnitude cosine I, magnitude sine j in your ij form, where your magnitude is literally Pythagorean theorem. All right, write a vector with length 7 at an angle of 135 degrees, positive x-axis in terms of magnitude and direction. All right, I know magnitude. I know the direction angle. And I've got the ability to find x and y, because x is the magnitude times cosine, 135, which is 7 times negative root 2 over 2. And y is magnitude sine. So that one's positive there. So vector v equals negative 7 root 2 over 2 I plus positive 7 root 2 over 2 j. Okay, vector travels from the origin to the point 3, 5. So remember, origin is the point 0, 0, and I'm taking it to 3, 5, which means our vector 3, 5. I went 3 units right, 5 units up. I'm going to get the magnitude and then get the direction. So the magnitude plus 5 squared. That's square root of 34. And we're going to get the direction, and I can use either thing on this. Either way, we can find that angle. I think there's a different way to do it. I don't know if you could use tangent. Inverse tangent to absolute value y over x. We're going to try it. Y over x. No, I forgot what it was. It's 3. Why am I writing 4? $59.036, which is right. right, that's not a unit circle value, so I can't do what I did here with cosine 135 and sine 135. Those were unit circle numbers. 59 degrees is obviously not a unit circle value. So we write it, vector v, magnitude, cosine, angle, I, magnitude, sine, angle, j. Our last thing we're talking about is something called a dot product. So the dot product is used to find the angle in between two vectors. So if I had a vector going off this direction, and I've got another vector going off this direction, then this would be used to find the angle in the middle. So the dot product takes the product of the horizontals and adds the product of the verticals. All right, so this is horizontal, verticals, and then we use cosine. Okay, cosine takes the dot product of the vectors divided by the product of the magnitudes. So we need the dot product, both magnitudes. All right, find the dot product of v, which is 512, and u, which is negative 3, 4. So v times u, horizontals, multiply those together, plus verticals, multiply those together. Negative 15 plus 48, 33. And it's as easy as that for that section. All right, find the angle between u and v. So if we notice, u and v are basically the same components as v and u over here. Actually, they are the same. So we already know the dot product. Okay, we're going to go ahead and find the magnitude of u. That's 5. We're going to find the magnitude of v. And that's 13. So then our angle is going to be the inverse cosine dot product divided by the products of the magnitudes. Dot product of the magnitudes. So the angle between them is 59.490. And that's it.